My name's Neil Kelleher, and I work at Northwestern University. I'm the Glass Professor of Life Sciences here, and we engage in whole protein mass spectrometry, otherwise known as top-down proteomics. And this is the idea of analyzing whole protein molecules without digestion. So in our research, one of the major goals is to test and ultimately explore the value of the idea that whole protein molecules can be strongly connected to and diagnostic of complex phenotypes in complex populations of humans. And so in disease, can we use top-down proteomics in a quantitative fashion to really explore and know the value of this kind of measurement? And this is what we do in transplant biology, kidney, liver transplants, as well as a lot of projects in oncology and cancer. So in our research, we place a really high value on three things of protein analysis. And this is all on whole proteins. And it used to be called next generation technology, but we think that the time is now to do quantitative analysis of proteoforms and then identify them, so specifically the molecule that they are, and then deeply characterize them with high content tandem mass spectrometry. And those three things are really what we're excited about in the Orbitrap Fusion Lumos, because it can do all three. There are several challenges of proteoform-resolved measurements. They are spaced tightly in mass to charge space. So the ability to pluck specifically one proteoform out of a mixture, it's something I've been wanting to do for a long time, and with the brighter source up front and the high resolution quadrupole of the Lumos, we're now able to do that on proteoforms that differ only by a few methyl groups and do that cleanly. So that experiment, along with high resolution, high capacity tandem mass spectrometry, it's enabling us to characterize whole proteoforms where we otherwise could not before. In the Orbitrap Fusion Lumos, we have a platform that really contributes and increases the power of all three of the things that we try to do well. So on the quantitation front, you have the ion trap backend, which is critical with its AGC, automatic gain control functions, to make sure that you're counting ions well. On the identification part, we want to pluck proteoforms specifically with narrow bandwidth isolation, and that's endowed upon the instrument with the front end quadrupole, and we're doing this at sub-1 Thomson resolution. And that allows us to pluck a specific proteoform out of a sea of highly related molecules in those that are even differing by 14 Daltons. For the characterization part, that's where high content tandem MS really is critical. And those are all three advanced in the Orbitrap Fusion Lumos. The time is now to do all three of those things really well, certainly in the 0 to 30 kilodalton regime, where the proteins are up to 300 amino acids. But for the next year ahead, we're clearly headed to the 30 to 90 kilodalton regime, a place where just a few years ago people thought that impossible. Now it's just clearly a matter of when. So there's a lot of interesting features about the Fusion platform and the tribrid technology that was released recently. But by far the most interesting feature, I believe, is speed. I mean, the thing is the fastest. When you combine high resolution and speed, there's nothing that touches it. So the speed aspect has really been needed for bottom-up proteomics to cover more proteome. And for myself, I look to harness that for top-down proteomics.